Hello and welcome to GMAT24 whiteboard tutorials. Today we are going to look at an interesting number theory problem on the GMAT-CAT 750 plus range. Because this problem appears on that range on the GMAT-CAT, you're not expected to do a lot of number crunching and computation, but to apply our understanding and logic on number systems. So let us visit the question right now. AB plus CD equals AAA, where AB and CD are two-digit numbers. And AAA is a three-digit number. A, B, C and D are distinct positive integers. What is the value of C? So, what we are given is AB plus CD equals AAA. Also, what we know from the question is AB and CD are two-digit numbers. And the individual values of A, B, C and D are distinct and positive. So A distinct for distinct, we know that A is not equal to B, is not equal to C, not equal to D, which makes them distinct. Also they are positive integers, which means A, B, C and D are greater than 0. So we don't really have to fiddle with negative numbers. As well as they are integers, so we can't, A, B, C and D cannot have values such as 1.1 or 2.5 and so on and so forth. So AB plus CD is AAA. So let us look at the right hand side of the equation, AAA. So we have two observations here. One is that, the first observation is that all numbers are the same, namely A. So this is the first observation. The second observation is AAA could take any of the values 111, 222, 333 and so on and so forth. However, we don't know whether the value of AAA is going to be 111, 222, 333, 444 or any of these numbers till 999. So let us look at the left hand side of the equation. So looking at the left hand side of the equation, we see that A, B, C and D are distinct and there is a constraint that we are imposed. However, we are going to assume that these numbers are not distinct and assign the same value to A, B, C and D to find out what could be the maximum value of AB plus CD that would result in a three-digit number. So, looking at A, B and C and D, the maximum value of a single-digit number to be more precise, integer. In our case, it's A, B, C and D would be 9. Hence, the left hand side of the equation could be written as 99 plus 99. And this gives us a sum of 198. So when we give A, B and C and D the maximum value 9, then the sum of the left hand side of the equation adds up to 198. Therefore, the value of AAA cannot exceed 198. So the values 222, 333, 444 and so on and so forth are no longer applicable because these numbers are greater than 198. Therefore, the value of AAA has to be 111, which implies that the value of A should be 1. However, this is not the solution that the question is asking us for. So we need to do a little more computation further. And to do that, we are going to apply a small, we are going to decompose the left hand side of the equation and the right hand side of the equation, eliminate some factors and arrive at the value of C. So we could rewrite the left hand side of the equation as 10A plus B plus 10C plus D. And the addition adds up to AB plus CD. Please check by applying some values of A and B and for yourself. Similarly, we could rewrite the right hand side of the equation as 100A plus 10A plus A. Looking at the left and the right hand side of the equation, we see a common factor 10A, common term 10A, which we could eliminate. Therefore, the equation boils down to B plus 10C plus D equals 101A. From earlier computation, we know that A has to have a value of 1. Therefore, the right hand side of the equation becomes 101. The left hand side of the equation remains the same, B plus 10C plus D. When we look at the left hand side of the equation, what the question is asking us to find out is what is the maximum value of C that brings the summation of the left hand side to 101. Because A, B and C and D are distinct positive integers, that is positive integers, we can't have any negative values of B and D. Therefore, we need to find out the maximum value of C that maximizes the equation and brings the summation to 101. So having maximum value of integer, as we saw before, is 9. So C has to have a value of 9 for maximizing the equation, because 9 times 10 is 90, and this is the maximum value that the left hand side of the equation could have. Therefore, this becomes B plus 90 plus D equals 101, or B plus D equals 11. However, we are not asked to find the values of B and D, which we could do so, but then we are asked to find the value of C. So C equals 9 is a solution to the problem. I hope you enjoyed watching this video. Have fun preparing for GMAT.